Let's revisit a concept that we've already talked about, but this time with a little bit of a twist, and that is systems. Now, previously when we solved systems, we were always dealing with linear functions. So for example, it'd be something like 2x plus 3y equals 17. I'm just pulling these numbers out of a hat. And, 3x minus 21y equals 87. Right? Please don't try to solve this because again, I just made these numbers up. But to illustrate that there's always one x and one y, and we're not squaring anything. But what happens when we do drift into more complicated equations? So for example, if it was something like 2x squared, right, plus 3y. Well, the answer is you don't do much different. You isolate one of the variables, right? You can isolate, in this case, x or y, and then substitute it into the other equation. The only hiccup this time being that you have a quadratic equation. So we're going to look at some problems and explore ways to solve these other than doing a whole bunch of algebra. So here are a couple questions to practice with. Let's pause the video and give these a shot. Starting over here. Which of the following are the solutions to the system of equations above? Now, you absolutely could solve this algebraically, and if that's your jam, go for it. In fact, the variable y is already isolated. So what we could do is just take this, negative x minus 2 squared plus 3, and set it equal to the other one because the variable, again, is already isolated. And if you want to do that, again, please go ahead. I feel like we've already done enough algebra, so I want to explore some other ways to do this, starting with plugging in, right? I always come back to that because it's a tried and true method. So what I could do, and I realize this is a little bit labor intensive, is test each point that I'm given here, 1, 1, and 1, 2. And I'm looking for 2 points that satisfy both equations. So for example, 1, 1 satisfies this equation. 2 times 1 minus 1 is equal to 1. And 1, 2 satisfies this equation, right? If I plug in 1 there, I square that, negative 1 plus 3 is positive 2. However, this one does not satisfy the second, and this one does not satisfy the first, so it's out. And again, to save some time, I'm not going to go through all this. I'm just telling you could do it. You eventually find that this is the correct answer. Now, in a minute, after we're done doing the other question, we'll return to this and solve it graphically using our graphing calculator to see how it's done. So put a pin in this, but just know you could solve it algebraically by setting the two equations equal to each other, or good old-fashioned plugging in method. Okay, so let's look at this one. The graph above displays two functions. F of x equals ax squared plus bx plus c, and g of x equals kx plus j. Now I'm going to pause right here. You might say, well, they're not labeled, are they? They don't have to be. You can look at just the format of both of these equations and know which one is the parabola and which one is the line. This is in quadratic form, ax squared plus bx plus c, so that tells us it is a parabola, right? So this equation, or this graph right here, is f of x. And g of x equals kx plus j. That's a linear function. It's a line. So that's g of x, right? And we know that a third function, not pictured, is defined as h of x equals g of x minus 17. How many real solutions will the system of f and h, a system of equations of f and h, have? Okay, let's back up here for a second and start with the system of equations that we do have pictured here, f and g. How many solutions are there between f and g? There are 2 points at which they intersect, and that means we're dealing with 2 solutions. But we're not asking about f and g, are we? We're asking about f and this unpictured one, which is h of x. Now, what do we know about h of x? We know that h of x is identical to g of x, but every value that comes out of it is 17 less. So for example, if I take g of x here and I label all these points on g of x, h of x is going to be the exact same picture as g of x, but it's going to be 17 lower, right? And I don't have the room to go all the way down here, but it's going to be lower. It's going to be like down here, right? Even further below. And what we see when we do that is that if we shift g of x down 17, I'll say minus 17, every point on g of x down minus 17, we create a line that does not intersect with f, which means that there are no solutions to the system of equations between f and h. Correct answer here is 0. So let's see if the machines can go faster than we can on this question. And unfortunately for humans, I think they have us beat. So here are the two equations that we're dealing with. 2x minus 1, that's one of them right there. And then the other one that we'll just write in is negative x minus 2, negative x minus 2, that whole quantity squared, plus 3. Well, I have my intersection points, right? One intersection point is 0, negative 1. The other intersection point is 2, 3. Those are my two answers.